Alright, so today we are going to look at factoring completely. Okay, when we want to factor completely, we want to first to make sure that we factor out our GCFs. Okay, so you want to factor out your GCF. You want to identify if you have binomials. Okay, with that you have the difference of squares or the difference of cubes or the sum of cubes. Okay, so you want to look at all three of those, the difference of squares, the difference of cubes, or the sum of cubes when you have a binomial. Again, you want to always make sure you do your GCF first. Then, the next concept that we looked at is our trinomials. With our trinomials still, we still want to look at the GCF, take that out first, and if it can't, we use that X method to factor. Remember the X method to factor. And the last step is our factor by grouping. Our factor by grouping is that we have our four terms, and even with the four terms, we must also still look at the GCF and take the GCF out first. Okay, so let's review. So if I give you the problem and tell you to factor 2x squared minus 4, okay, before you begin, very first thing you want to do is check for your GCF. Here, your GCF is 2. So we said we would divide everything by 2. So 2 on the outside. 2 goes into 2 one time, you left with x squared. 2 goes into 4 two times, so you get 2 times x squared minus 2. Now 2 is not a perfect square, so this is our answer. Okay, that's our GCF. Okay, but then if we have this x squared minus 9, so now we have a binomial. So we want to ask ourselves, well, is the first term a perfect square? It is. Is the second term a perfect square? And it is. So we can just say that this is now going to be the difference of squares, which is x minus 3 times x plus 3. Then we have our trinomial. Our trinomial that we're going to look at is going to be x squared plus 2x plus 1. Okay, so we do our x method. The 1 goes here, the 2 goes here. What factors of 1 that will give us 2? 1 and 1. So then this becomes x plus 1 times x plus 1. Now we got to make sure we write this. If we don't, it won't be correct, because this is just the method that we use to factor, but we must factor. Okay? And the last type of problem that we're going to look at is going to be our cube. So if I have y cubed minus 7y squared minus 9y minus 63, and I'm running out of room, so I'm going to go ahead and change the page. So that was y cubed plus 7y squared minus 9y minus 63. Okay, so here's our four terms. So we said we're going to factor by grouping. We're going to group the first two. We're going to group these two, and we're going to put a plus sign in between there. Okay, our GCF here is y to the second. So we put the y squared out. Y cubed minus 2 is going to give me y, because 3 minus 2 is 1, plus y squared divided by y squared is 1, and we're left with a 7, the plus sign. But we're not going to use a plus sign because we're going to factor out of here the GCF is negative 9. So we put the negative 9, and a negative times a positive will be a negative. Parentheses, y, negative divided by negative is a positive, plus 7. We now see that these two are alike. So since those two are alike, these two can be grouped together. So we get y plus 7 times y squared minus 9. And then we can factor the y squared plus 9, minus 9, because it is a perfect square, or the difference of squares. 9 is a perfect square, so we can factor it. Okay? Alright, and the next problem that we didn't really talk about this problem, but I want you to look at it, because I know we can do it. So we got 3b to the 6th plus 6b to the 4th plus 3b squared. So we're going to follow the same concept where we take out the GCF. If we look at this particular problem, we have a b, b, and b. We got 6, 4, and 2. So our common is 2. So we know we're going to have to divide by b to the second. But this is 3, 6, and 3, so that GCF is actually 3b to the second. So we're going to divide by that. That's our GCF. GCF. Okay, so 3 goes into 3 one time. B to the 6th divided by b to the second is b to the 4th. 3 goes into 6 two times. B to the second divided into b to the 4th is b to the second. Plus 3 goes into 3 one time. B goes into b. That gives me 1, so that's going to give me 1. Now this is where it becomes a little bit different, because now we got b to the 4th, which is a perfect square. We have b squared and we have the 1. So what we do in this case is that we sit here and we rewrite this. We rewrite this as b to the second squared plus 2b squared plus 1. Okay, so it's like a substitution method that you can look at that you're doing. So this is a perfect square. 1 is a perfect square. So if we look at that, this would give me 1. This is 2. What factors of 2? But this is 2 what? B. What factors of 1 would give me 2? 1 and what? 1. But it has to be what? The B there. So it'll be 1B. Well, we don't necessarily have to write it like that. You can write it like this. We'll just take off the B and we'll know we have to add the B in the end. Okay. So that tells me that this right here is factored to B. We got to keep the 3b squared. B to the second plus 1 times b to the second plus 1. And we can always check to make sure, because we had b to the second to the 4th. This is the same thing as saying b to the second squared, and so that's a perfect square. 1 is a perfect square, so when you multiply those two together, you're going to get the middle term. Let's check to make sure. B times b is b to the 4th. B times b squared times 1 is b squared. 1 times b squared is b squared, and then 1 times 1 is 1. So we get b to the 4th plus 2b squared plus 1, which is what we have here. So the answer is this right here, is our final answer. And we just checked it to make sure. So we actually ended up having a trinomial within the actual finding of the GCF. Okay, let's look at one more problem like that, and then we'll be done for tonight. Again, remember, this is just a trial to see how it works and see how well you guys take to this. So we got x to the 4th minus 7x plus 12. Okay, well, what can we do here? Well, we do know the tree. This is a 12. This is a negative 7. Okay, so this is like saying x to the what? Second raised to the what? Second power. What factors of 12 would give us 7? Has to be 4 and what? 3. and the sign's got to be the same, because negative 4 times negative 3 is positive 12, and then negative 3 plus negative, I'm sorry, negative 4 plus negative 3 is negative 7. So now we can write our terms out to be x squared, because this is the square, minus 4, then x squared minus 3. It's a little difficult when that is a 4 up there. Now you see here is the difference of squares. So we say x minus 2 times x plus 2. And of course we got to bring down our x squared minus 3. Alright, let me know what you guys think. Again, remember this is our trial that we were doing. So I'll see you in the morning.